chemistry. In this video we're going to be taking a look at the chemistry of glass and colored glass. Albeit this will be a very brief and not comprehensive look at glass in the chemistry or the history of. We just want to kind of take an overlook right now because this will coincide with our field trip to the glass blowing studio that we'll be taking, and I want you guys to kind of have an understanding of what you're going to be seeing on that trip. So to do that, we want to just first take a look at the components of glass. So glass for the most part is called soda lime glass. It comprises 90% of manufactured glass today, so modern glass. Soda glass is three main compounds: silicon dioxide, calcium oxide, and sodium oxide. Okay, and there's varying percentages of these particular compounds in modern glass now. So soda lime glass is commonly used in glass bottles and windows. Now let's take a quick brief history of glass. So when we first try to find where glass was made, the earliest findings take us to the Egyptian times where they first started using glass. Now unfortunately I wasn't able to find any images from archaeology that show examples of this type of glass, but what I was able to find is some Roman examples of cameo glass. And if you can see, it's pretty, it looks like the design or the making of the glass itself wasn't super technical, but when you look at the designs that they imprinted on the glass, it's pretty amazing. I would love to have one of these vases in my living room. But you can see here that the glass is pretty opaque, it's pretty dark, but nonetheless it has stood the test of time, much like a lot of Roman technology, and it served its purpose. So looking a little bit further ahead in history, and looking at the 10th century and beyond, we see medieval stained glass. Now, the vast majority, if not all, of glass examples from the 10th century on are basically from the churches that the medieval church used. When you stop to consider the historical context, the medieval church was the richest and most powerful institution at that time. So it makes sense that they would have these elaborate and expensive techniques being used in their buildings. And you can see here that they made some pretty elaborate designs with the stained glass, and they also used chemistry to develop the different colors so that they can actually, they actually look like, well, not like pictures, but they resembled actual living real life images. So you could actually color the clothing and the sky and what have you. So they really started to perfect some of those techniques. And when you look at today's use of stained glass, it looks pretty close to what they had, but a little bit more intricate. Now this is an image of the largest stained glass display in the United States. This display is about a football field long. This is located in a church in Kansas City, and they have this displayed above their sanctuary. So one of the questions that we want to explore is how we get to develop works like this, where you can see the intricacy and the different colors. I really like this piece because it has basically the full range of the full spectrum of colors that we can have, and of course there's more that aren't there, but for the most part we can see the variety of colors. And we want to explore how we get color in glass, because that's one of the things that will be discussed at the glass blowing studio. So for this we need to go back to the periodic table, and in particular we want to look at the transition elements in the periodic table. So that's our D block in the periodic table. This is where you'll find our traditional metals like iron, cobalt, nickel, copper, and such. These metals play a very important part in developing color in glass. So recall that every element has a specific energy signature, and that energy signature is due to the valence electrons the element has. Recall that every element has a certain number of electrons, and those electrons are located in certain orbitals of that element, and when they get excited they jump energy states, and then when they go back to a ground state they release that energy, and that energy, that specific frequency, that wavelength is a specific color. Okay, so that wavelength is a specific color. That's the energy that we see as color. So at the end of the day, when we see color, we're actually seeing energy. Our brain is just absorbing that information and translating that into what we've categorized as color and what we've named specific colors to be, or specific wavelengths to color. So back at the periodic table and looking at the d orbitals, or the d block of the periodic table, recall that each element again has a specific energy signature, because this plays a very important part in developing color in glass. Okay, so you might use a specific element or combination of elements to get a desired color. So for example, let's look at iron. Iron, when you so basically what they do is they powder up iron and then they mix it into glass and it gives off this color. Okay. Iron plus sulfur gives us a nice little reddish brown color. Copper is a blue color. You might recall that in chemistry when we use copper sulfate, for example, copper that is in a solution, it has that bluish color. When we combine copper and tin, you get a nice little red color. Nickel, a brownish color. Gold, a reddish. And cadmium, you actually get a goldish color. So as you can see, every element here, every element gives us a specific color signature. So here's a few more examples of what you can get from various elements. So you can kind of pause it here and take a look at the different metals that you have and the colors that they give off. And I mean, the list goes on and on. It continues to grow, and you can see we have some pretty elaborate colors. And you can mix, like we mentioned before, you can mix these elements to get different shades of a color that you want. And again, keep in mind that all of this has to do with the electrons that a particular element has. Now, when these elements combine and when they're powdered up and they're molted into glass, so as light shines into the glass, depending on the geometric shape of these elements of the metals that are involved in this glass, so light will shine into the glass. A lot of the energy will be absorbed, and then some of the energy will be reflected back. Okay, just think of photosynthesis. A plant will absorb most wavelengths except the color that you're actually seeing, and most plants, the vast majority of plants, give off a green color because of chlorophyll. So you have a plant that is absorbing every color except green. Okay, so here you have a bottle that's absorbing every color except whatever color you're seeing. When we go to the glass blowing studio, you're going to see something like this. You'll have little trays, and they'll actually demonstrate these for you, and you'll get to handle them. And you'll see that these different bowls with the different colors, these are powdered metals. And these are the metals that they use to make different colors. So what they'll do is they'll mix them up, and they'll roll molten glass over these metals. This powdered glass starts off as metal rods that you see here. Okay, so they'll have different metal rods that have different colors, and then they'll ground them up and powder them and use them in the glass blowing. So what you're going to see on this field trip is we're going to walk into a furnace. Now, of course, we'll be at a distance because we're not trained to be as close as these guys will be. You're going to walk into a furnace, and the hottest furnace is called a glory hole, and that gets up to about 2400 Fahrenheit. And so, like I mentioned before, they'll roll the molten glass over the powdered metals, and then they'll pop it back into the glory hole. That way that metal will melt into the glass, and it'll get integrated into the glass itself, and they just spin it and blow. That tube that you see there, they blow into that tube, and the glass slowly inflates like a balloon. And it's a process where they keep bringing it out, and they'll roll more glass or more metals into it. And it's a process where they keep putting it in and out, and until they get the desired design and shape. And when they bring out the material from the glory hole, they will shape it using different tools. And here's an example of one you have, and they use these tools to shape the glass, and they make these amazing vases. Now, I'm really fascinated and curious and I would love to see. Too bad we don't really have any depictions of how the Romans made their glass. But you could imagine that it was a very similar process to what we use today, also with the medieval techniques that they had. So that does it for this video on chemistry of glass and colored glass. I hope this was educational for you, that you learned something new, and look forward to our field trip. So make sure that you watch this and you understand the basics of the chemistry of glass. Thanks for watching, guys. Good luck in your study.